All right, so first one says which of the following graphs are one-to-one? Which of the following graphs are one-to-one?
Just C.
Just C?
All right, just B.
Just B.
Yeah.
Only B. Because B is the only graph that would pass the horizontal line test. Okay, you got it right? Okay. If they're not one-to-one, section the graph into parts that are one-to-one. So how could I section this graph into parts that are one-to-one?
Section it right down the middle.
Right down the middle. So I cut it right down the middle, then this piece and this piece separately would be a good deal. How about this guy right here?
Right there.
Right where that little low point is?
Right there.
Okay. Do we have to do it again? Oh yeah, we got to do it again. All right, good call. So that one would have to go into 3 pieces. And then this piece would pass the horizontal line test, and this piece would pass the horizontal line test, and this little piece behind most feet. How about D?
Can't do it.
Yeah, I can't do that. No way you can do that. Okay. Absolutely no way. All right, so any questions on that one? Allie? You good? You see from back there? You don't have to sit back there. Okay. Okay, next one. Show that for every value of a, the function f of x equals a plus 1 over x minus a is its own inverse. How are you going to do that? What's that? Switch the x and the y. So this right here is the y, right? F of x and y are the same thing. So I'm going to rewrite this as x equals a plus 1 over y minus a. Now I have the unfortunate task of solving that for y. Subtract a. Okay. Don't really know where this is going to go. So x minus a equals 1 over y minus a.
And then flip both sides.
Flip both sides.
Yeah.
Can I do that?
Like the one.
You think so?
Yeah, and like make it 1 over x minus a and then.
Okay, so you want me to go 1 over x minus a equals y minus a over 1?
Yeah.
Just flip them over. You think you can just do that?
Yeah. Yeah.
Pretty much.
Can you?
Yes, Jenny said so. And so y minus a is really, y minus a over 1 is just y minus a, right? And then how do you solve that for y now? Add a. And what do you know? You got what you started with, so it must be its own inverse. Flip them, huh? Wouldn't have thought of that.
Being smart.
Jenny's smart. Okay. All right, any questions there?
Okay.
All right. Oh, now we get into the fun stuff here. All right. It says a biochemical experiment involves combining together 2 protein extracts. Suppose a function. Anyone got that Greek letter? What was feet? I'm going feet, like F-H-I. I don't know if that's right. Monitors the amount in nanograms of extract A remaining at time t in nanoseconds. Assume you know these facts. First thing you know is the function phi is invertible. In other words, it has an inverse function. And then we have these different values. After 0 nanoseconds, there would be 6 nanograms left. After 1 nanosecond, there'd be 5, 2, there'd be 3, and so forth, okay? All right, at what time do you know there will be 3 nanograms of the extract remaining? 2 nanograms? Yeah, it looks like right here, when t is 2, there's 3 left, okay? So that would be at t equals 2. What is the inverse of phi to the phi 0.5, and what does it tell you? And remember, when you're doing inverses, you are so the way Kenny solved this problem is it said, when will there be 3 nanograms left? So we look for the 3. Here we want the inverse of 0.5. So what's the answer from here? 4. Yes, this guy right here. Okay, because of saying what is, how, instead of saying how many nanograms are left after 0.5 seconds, it's saying when there are 0.5 nanograms left, how many seconds have passed. Okay, so the inverse of that would be at t equals 4. All right, true or false, there's exactly one time when the amount of extract A remaining is 4 nanograms. True, because if you are told that this function is 1-to-1, if you look at the graph, let's say that this was false and there were 2 different times that there were exactly 4 nanograms, saying one was this time there and one was this time there, so there would be a point right there and there would be a point right there. Would this function be 1-to-1 anymore?
No.
No, because it would fail the horizontal line test right there. Okay, so that means that this is going to be true, and that's the whole 1-to-1 idea. Oh, pay better attention. Gosh, I only have like 3 more left, and then you can just sit around. I'm going to give you an assignment, but you never do it anyway, so.
I tried doing it the other day, actually.
All right. Okay, now let's calculate, let me write this over here so we can see it better. Phi of the inverse of 1. Okay, so let's do the inside first. What's phi inverse of 1? We're going to cancel each other out. Yeah, no, he's right. If you take the function, well, we'll see. Kenny will explain in a second. Phi inverse of 1, remember that's going to be this guy right here, right? Instead of looking where you plug 3 into the function, you're looking where you get 1, I'm sorry, instead of looking where what you get when you plug 1 into the function, you look at where you get 1 as an answer, and where you get 1 as an answer is at 3, okay? So phi inverse of 1 is 3, so then now we need to figure out what phi of 3 is. What's phi of 3? 1, okay? And so Kenny knew it doesn't matter right off the bat, because if you do the inverse and then you do the function, since they're inverses of each other, they cancel out. And you're just going to be left with this guy right here, okay? So what is the phi inverse of phi of 6? 6, because the inverse of the function will cancel, and you'll just end up with 6. Alright, and finally, what is the domain and range of phi? What's the domain, the x values? What's our lowest x value? We're talking about time. So yeah, the lowest one, it goes from 0 to what? 10. Right. And what is the range? What is the lowest output that you get? 0 to 6. Because now I'm looking at the y's. Okay? Yeah, easiest, shortest assignment ever in this class. Probably, legitimately, not even being sarcastic.
No, I was.
I'll go ahead and
Yeah, good.